Hi everyone, why we use hyper-heuristic? According to Rice, when we select or generate new heuristic, we design a new algorithm, which is better than just adjusting its parameters. So Polly et al. 2008 and 2009 proved that there is free lunch hyper-heuristic has been proven that there is a free lunch hyper-heuristic. Thus, it would be possible to design a good method that can work well across different domains. This is the classification of hyper-heuristic based on the nature of the search space. So hyper-heuristic can be classified as heuristic selection or heuristic generation. Many researchers focus on the heuristic selection mechanism. So under heuristic selection mechanism, we'll have a construction hyper-heuristic or perturbative hyper-heuristic. So in the heuristic selection mechanism, usually it is fixed or human designed low-level heuristic. So usually we deal with the human design low-level heuristic, or the number of low-level heuristic is. However, for heuristic generation, the heuristic component is used to generate either a constructive hyper-heuristic or a perturbative hyper-heuristic. We will look more on this in the following slides. So the hyper-heuristic can be classified based on the nature of heuristic search. So heuristic to choose heuristic. So this hyper-heuristic methodology which control the selection of which heuristic should be called from a given pool of heuristic and then applying them to the current solution. So this is called heuristic to choose heuristic. That means the higher level of hyper-heuristic will choose the low-level heuristics. The other one is the heuristic to generate heuristic. So this methodology focuses on designing new heuristic by combining existing heuristic component and then applying them to the current solution. So the nature of heuristic search space can be classified based on the type of the low-level heuristic as either is it a constructive or the perturbative hyper-heuristic. So constructive-based hyper-heuristic start with an empty solution and incrementally builds it by selecting suitable constructive low-level heuristic from a given pool of heuristics. So in other words, the constructive-based hyper-heuristic deal with the constructive low-level heuristic. The other one is the perturbative-based hyper-heuristic. So it starts with the initial solution and iteratively perturbs the solution by selecting an appropriate improvement low-level heuristic from the candidate set of heuristic. That is, the perturbative-based hyper-heuristic deal with the improvement low-level heuristic. So perturbative-based hyper-heuristic. This is the step of the perturbative-based hyper-heuristic. Given a set of perturbative low-level heuristic, or we call it improvement low-level heuristic, a complete solution and the objective function, the perturbative-based hyper-heuristic successfully invoke the following step for a certain number of iterations. First, they call the heuristic selection mechanism to select from a given pool of the perturbative low-level heuristic. Then, apply the selected perturbative low-level heuristic to a given solution to generate a new solution. Then, we call the objective function to evaluate the generated solution. If it is better than the incumbent solution, we replace it with the new solution and continue the search. Otherwise, call the acceptance criteria to decide either to accept or reject the generated solution. If the stopping condition is not satisfied, update the parameters value and start a new iteration. Otherwise, stop and return the best solution found. So this is the main step in the perturbative-based hyper-heuristic. So in perturbative-based hyper-heuristic, we have the acceptance criteria. So there are various types of acceptance criteria. These are the example of acceptance criteria that can be applied at the perturbative-based hyper-heuristic, or we can apply them in the constructive-based hyper-heuristic. So accept only improving solution or equal. So this means that any solution written by the low-level heuristic will be accepted if they are good or equal quality. Then we have accept all solutions. So for this one, we accept any solution. Either it is good or it is not good, regardless whether for this acceptance criteria, we accept any solution written by the low-level heuristic, regardless of if it is good or it is not good. So then we have a similarity annealing acceptance criteria. So the solution written by the low-level heuristic will be accepted based on the annealing probability of acceptance criteria. Great deluge. So the solution written by the low-level heuristic will be selected or will be applied depend on the great deluge acceptance criteria. Similarly, with record-to-record travel, exponential Monte Carlo with counter, TABU search acceptance criteria. So I hope that you have learned this in the previous lecture. So this further classification of the hyper-heuristic. So this is based on the source of feedback during the learning mechanism or source of feedback. This is further classification of the hyper-heuristic based on the source of feedback during the learning. So we have online learning, we have offline learning, and we have no learning. So for what is online learning? Learning while solving a single instances. So it is adaptive. For example, is reinforcement learning, or we can use meta-heuristic approach to learn the feedback. Offline, gather knowledge from a set of training instances, then we generalize. So example is a classifier system or case-based reasoning and so forth. Okay, let's proceed with a hyper-heuristic using selection mechanism with no learning. This is just example. There are many more. Simple random mechanism. Simple random mechanism. Randomly select from a given set of heuristic, one low-level heuristic at each time. Random gradient mechanism. The low-level heuristic is randomly selected, but this low-level heuristic will be applied as long as the given solution is improved. Random permutation mechanism generates at each iteration a random permutation of low-level heuristic and apply them one after another in a successive manner. Greedy mechanism. Apply all low-level heuristic to a given solution and select the best performing one. Package mechanism. Combine greedy and random selection mechanism. A low-level heuristic is randomly selected from a given list of best low-level heuristic. Tournament selection. Use simple random heuristic selection with a tournament factor. So let's proceed with hyper-heuristic using meta-heuristic selection mechanism. Either we have no learning or with a learning mechanism. It depends on the meta-heuristic itself. For example, TABU search. So TABU search, we have a learning mechanism. We have memory where we keep this TABU search. We have TABU list to keep the information about the previous search. Then we have N colony optimization. For N colony, we also have a learning mechanism where N save their pheromone during the search. Genetic algorithm Also, we save a pool of solution, and the new solution is generated based on the pool of generated solution. Honeybee mating optimization also have a learning mechanism. Scatter search and harmony search, hyper-heuristic. So let's see example of hyper-heuristic using meta-heuristic selection mechanism. Genetic algorithm, each individual in the population comprises a sequence of integer value, and each one represents one low-level heuristic. So a TABU search, at each iteration, the heuristic selection mechanism greedily select the best low-level heuristic, and if its application improves the solution quality, the solution will be accepted, and this low-level heuristic will be released from the TABU list. If present, a non-improving low-level heuristic is selected if it is not in the TABU list and inserted in the TABU list after its application. Okay, example of TABU search hyper-heuristic. At each iteration, the heuristic selection mechanism greedily select the best low-level heuristic, and if its application improves the solution quality, the solution will be accepted and the low-level heuristic will be released from the TABU list. So a non-improving low-level heuristic is selected if it is not in the TABU list and inserted in the TABU list after its application. So this is one example of applying TABU search as a hyper-heuristic. So hyper-heuristic using learning mechanism. Use the current search state or the previous performance of individual low-level heuristic in determining which low-level heuristic should be called. Each low-level heuristic is associated with one or few performance measures. So these measures are combined in a systematic manner to produce a score for each low-level heuristic that will be used to choose one low-level heuristic to be applied at the next decision point. So that means in the hyper-heuristic that have learning mechanism, they have a performance measure to identify which low-level heuristic to be selected based on their previous performance. And the current search state performance of the search space will also be evaluated to determine how to call the next low-level heuristic to be applied. The main step for the hyper-heuristic using learning mechanisms are: first, initial score. All low-level heuristic require an initial score which is usually set to 0 or a very small value. Then we determine the memory length adjustment is to determine how long the previous search performance will be saved. Mechanism to select the low-level heuristic based on the associated score. Given a set of low-level heuristic and their score, the selection can be performed in several ways. For example, maximum selection mechanism, that means we choose the best performance heuristic or the best score, roll weight selection mechanism, and many more selection mechanisms. Score updating mechanism. For example, add 1 for the improving low-level heuristic scores and subtract 1 from the non-improving low-level heuristic score value. So the researcher can design how to update the score. Intelligently design how to update the score. So this is one of the research area that some researchers focus to design a good hyper-heuristic. The comparison between hyper-heuristic to choose heuristic versus hyper-heuristic to generate heuristic. Hyper-heuristic to choose heuristic usually supplied with a set of human design heuristic. The role is to select at each decision point one low-level heuristic to be applied at a given solution. So hyper-heuristic to generate heuristic. We supply with heuristic component. The heuristic component can be like simulated annealing acceptance criteria, the move operator, the what we call the heuristic selection mechanism. There are many more heuristic components. So the role is to generate new heuristic by intelligently combining these given components. So the role of high-level strategy is to fabricate new low-level heuristic by combining existing heuristic components rather than selecting from a set of pre-supplied low-level heuristic. This is different between the hyper-heuristic to generate heuristic compared to hyper-heuristic to choose heuristic. So the hyper-heuristic to generate heuristic will produce a new heuristic. That means for this heuristic generation, we might combine, we might hybridize TABU search with simulated annealing, with genetic algorithm, and many more. Depend on what component is selected to form the new heuristic. So the example of hyper-heuristic to generate heuristic, genetic programming. So GP, many researchers use GP to automatically generate the low-level heuristic for numerous combinatorial optimization problems. An evolutionary algorithm, it is an evolutionary algorithm known as program generation method that use an evolutionary process that is crossover and mutation to evolve a population of computer programs. The output of GP is a computer program instead of a solution itself, and this program, when executed, will generate solution to a given problem instance. Okay, let's proceed with the example of graph coloring constructive hyper-heuristic for examination timetabling problem and the simulated annealing hyper-heuristic for university course timetabling problem. So for graph coloring constructive hyper-heuristic, let's say we have 4 low-level heuristic. This low-level heuristic 1. In this heuristic hybridization, we have largest degree plus largest enrollment plus saturation degree plus largest color degree. So in this heuristic, in this low-level heuristic, the exam to be scheduled are arranged in a non-increasing order of the number of conflict they have with other exam. So those with equal largest degree evaluation are then arranged in non-increasing order of the number of student enrollments. Then in a non-increasing order of the number of available time slot. And finally, in a non-increasing order of the number of conflicts the exam has with those already scheduled. Similarly, for H2, this heuristic hybridization start with saturation degree, combined with LCD, combined with LD and LE. So arrange them, arrange the exam to be scheduled by using SD first, then LCD, LD and LE hierarchy. So similarly for H3, with different hierarchy, and H4 with different hierarchies. So in the hyper-heuristic level, first we do the initialization, generate the 4 ordering list of exam by using HI. So HI for 1 to 4. So while ordering lists are not empty, that means we have exam in the ordering list that has not been scheduled yet. We do this step. Calculate the difficulty index of the first exam in each of the lists. So we have 4 lists, H1, H2, H3, H4. So we calculate the difficulty index of the first exam in the list. I do not show you how they calculate, but you just assume any formula to calculate their difficulty index. They can use the order of in the list as a difficulty index. So let's say exam 1 in let's say exam E. Exam E in H1, exam E appears at the first order in H1. So exam A might appear and maybe in the third order in H2. For H3 maybe in the second order. For H4 might be in the fifth order, for example. So we can calculate their index, total up their index, and we get one total value. Similarly for exam B, for example, maybe in H1 it appears at the third order. In H2 it might appear at the first order. H3 might be the fifth order, and so forth. So we pick the exam in the first order of each of the list, and we calculate their difficulty index. So select the exam that has minimum difficulty index. So among 4 exams that we calculated, among the 4 exams that we have calculated based on the order of the list, we select the one that has the minimum value of difficulty index. So if we have more than one exam with same difficulty index, randomly select one exam if there is more than one exam with the same difficulty index. Okay. If we have more than one exam with same difficulty index, we just randomly select one of them. So assign exam E to the time slot selected based on the roulette wheel time slot selection. So how are you going to do this is up to you. You can just measure the number of what we call the number of exam in that time slot, or some evaluation that you can use to include in the roulette wheel selection. So remove E from all ordering lists. Once you have assigned the exam to the time slot, so you remove from the list, then you reorder all the ordering lists using H1 to H4, and the same process is repeated. So until all exams are scheduled. That means the list, all the lists are empty. So verify all the hard constraints are satisfied. If the ordering lists are empty and all hard constraints are satisfied, then return the feasible solution. Otherwise, return infeasible solution. Okay, let's proceed with the example of TABU search hyper-heuristic. So step 1 is construct initial solution. So at the hyper-heuristic level, the initial solution is the initial solution of the solution here is the low-level heuristic. Step 2 is consider heuristics that are not taboo. Apply chosen heuristic and make the heuristic taboo. Update the solution until termination condition is met. Okay, let's proceed with a TABU search hyper-heuristic example. First, construct. Okay, let's proceed with the example of TABU search hyper-heuristic. First, construct initial solution. So in order to proceed, we must have initial solution. In step 2, consider heuristic they are not taboo. For the first iteration, all the taboo lists are empty. So we just we can consider all the low-level heuristic. So apply the chosen heuristic and make the heuristic taboo. Update the solution. So until the terminating condition is met. This is just a basic TABU search. So this is example of simulated annealing hyper-heuristic, same as the common simulated annealing, but we use this as the hyper-heuristic simulated annealing. What is the difference? The difference is the solution that we work. So in the hyper-heuristic, we are dealing with the selection of low-level heuristic. So let's have a look on this. We begin, select a heuristic. So when we select the heuristic, we apply the selected heuristic to solve the solution. And then we test SA acceptance criteria. If the solution return is acceptable, then we accept that solution. If it is not acceptable, so we reject the solution. So the acceptance of the solution, we use the simulated annealing acceptance criteria. Then we update the SA parameter. So remember the SA parameter, you need a cooling schedule, the temperature, reduce the temperature, and so forth. So if the termination condition is met, if it is not yet, then you proceed with select heuristic. So how to select heuristic? You can just randomly select, or you can use any selection mechanism that we have go through before this to select the low-level heuristic. So by using this, what we call this hyper-heuristics framework, we can work such as like variable neighborhood search, or we work as a hybrid algorithm where we can have many heuristic as a low level. The low level heuristic can be meta-heuristic too, can be just a move operator, can be just a swap operator. So the framework of the hyper-heuristic allow the researcher to combine different neighborhood structure, different meta-heuristic in one method. So this process is repeated until the stopping condition is met. So this is the pool of low-level heuristic. We have objective function value to evaluate the quality of the solution, and we also need the initial solution. So this general idea of simulated annealing hyper-heuristic, this is a stochastic heuristic selection mechanism. We apply the selected heuristic, test on the simulated annealing acceptance criteria. So the collection domain independent function from the domain barrier, for example, number of heuristic, the change of evaluation function, a new solution, the distance between two solutions, whether it gets stuck or not. So all this can be used as a feedback, either to accept the solution or to reject the solution returned by the low-level heuristic. Okay, with that, I end the talk today, and all the best for your future. Thank you.